Thanks again, guys, for everybody coming to this webinar today. My goal of this webinar was to help people better understand the whole concept of scheduling. I've spent a lot of time in my career working with people involved in construction projects on understanding project schedules, and one of the things that became very clear to me was that a lot of people don't actually understand it. So today I want to give everybody an understanding enough to be dangerous. And when I say dangerous, that means capable, being willing and able to sit in a meeting, listen to the terms, and understand actually what's going on when you hear words like float or critical path or delay or extension of time. All those key words that we hear often need to be understood by most participants, and they're not generally understood by most participants. Who am I? My name is Michael Pink. I'm a guy who has spent pretty much my entire career studying data, even back into college. I was an industrial engineer. I also got into my first career job at Deloitte and KPMG and FTI, companies like that, doing construction schedule and delay analysis, usually to help people get through claim situations. But what became very, very, very clear to me was that there's a disconnect between what does all this information really mean and how do we understand it. I am now the founder and CEO of a company called SmartPM Technologies. What we do is build software to help better understand schedules. So I am very into this problem. I've spent my entire career trying to understand this problem, and I come at you today trying to teach you what I've learned in a short amount of time so it doesn't necessarily impact your day job. What are we going to cover today? First and foremost, I want to talk about why is this necessary and who is it for, this exact presentation. Once I get through that, I'm going to talk a little bit about the building blocks of CPM scheduling. I will get into some very, very basic things, but also talk a little bit about how does the CPM algorithm work. I'm a big proponent of understanding why and how ultimately teaches us, a lot more than just what and where. We'll talk about schedule quality because to me, that's one of the biggest roots of all scheduling issues in the industry is the quality and lack thereof. And explaining what is important about quality and how to analyze quality is very important. Understanding the concepts behind it and actually some of the metrics. Then I'm going to get into talking about updating. Scheduling updating is a very important thing. It doesn't always happen on every job, but I want to explain today why it should happen, how often, what are the do's and don'ts. Then I want to talk about changes. Changes to schedules is an enormous problem, something that's resulted in a lot of disputes. So I want to talk a little bit about that because I think it needs to be monitored. And then the last thing I'll talk about is delay. All this scheduling stuff is about making sure that projects end on time, yet we continue to see that projects are delayed. And understanding those delays are important because delays are costly and people fight over them. So I want to talk a little bit about that such that at the end of this meeting, I want to burn into your brain pretty much the ins and outs of CPM scheduling from a conceptual level such that anybody can sit in a meeting and actually have an active discussion about it and understand it. So I'll talk a little bit about this. Who is this for and why is it necessary? This is really for all the people out there who aren't schedulers, people who don't sit on Primavera every day, but they are involved in construction and live and die by the schedule like we all do. That includes basically everybody but schedulers. This is really where a problem exists, in my opinion. I think that back in the 80s when these scheduling programs were rolled out, they didn't come with a user's manual. The software did, but not the best practices behind how does this software work well. So the entire industry inherited this new technology that's supposed to be very meaningful, and as a matter of fact, it is very meaningful and useful. It's just the industry as a whole hasn't actually gotten to that place where they actually understand it. To a point where everybody can speak fluently in this subject matter and actually have meaningful conversations, because generally speaking, most people don't understand it at an intimate level. The schedulers do, and that's really, it's become a challenge in actually understanding what's going on the projects and actually in the schedule to control risk of all parties involved. So this is for everybody. If you are a scheduler, feel free to sit and listen. I'm sure you'll know everything about what I'm going to be talking about, but more importantly, this is for the people who are out there who are decision makers, who do need to understand this information, and that's not necessarily do. And hopefully at the end of this discussion, you'll walk out of here with a lot of good insights and will speak fluently in schedulese, as I like to call it. All right, I'll move forward. So what is CPM scheduling? A lot of people denounce CPM scheduling because they think it's a waste of time and energy because it results in a lot of problems. But in its most simplistic form, it's an algorithm or a methodology that allows people to assign activities and relationships among those activities to create a plan, and a plan that's not only lays out what things are supposed to happen, but it also prioritizes the activities based on, you know, the urgency or the risk related to those activities in specifically impacting the end date. So what you get when you use a CPM schedule is a plan. And that plan actually comes more than just activities. It's a prioritized list of activities of what activities are higher risk activities that need to get done as timely as possible, and which ones have a little bit of room for delay, and which of them have a lot of room for delay. So really that's useful. Useful knowing if you have a complex construction project that you can actually look at a schedule, look at a technology, and it will tell you, here's what's going on today, here's what's going on tomorrow, here's what's going on the next couple weeks, and here's the order in which they should be completed. Here's the ones that absolutely need to get completed in time, and here are the ones that have a little bit of room for error. And why is that important? Well, we all know in construction that getting the right number of resources is a challenge. So distributing your resources is imperative towards success. And if you're not putting your resources on the most important activities of the highest risk of doing one thing, and that's impacting the end date, then you're most likely going to mismanage your job and have inefficiencies and overruns. So CPM scheduling is very powerful. It just needs to be better understood. Here's what a CPM schedule looks like, and it's broken into different components. Number one, every activity has a unique identifier. A number that separates it from everything else. So it's that one activity with that identifier. It needs that identifier for the program to actually understand it. Then there's activities with descriptions and durations. Right here, you can see that we've got these activities. They have a description, they have a name. It represents a discrete work activity. And it has a time frame, a duration. So you need to have a time frame and an activity of what exactly does this thing represent and how long is it going to take. And the next major component is what we call relationships or logic. You know, every one of these activities, they're related to something. They can happen. They should happen before something, and something should happen before them. You know, if we lived in a world of no relationships, people would be trying to put roofs on before they put the foundation in, and we know that that can't happen. And these technologies out there can't figure that out. So it's required that the user enter into the system. What's the order of operations here? What work needs to precede what other work? And that's what we call relationships and logic, predecessors and successors. And then all of that is overlaid on a calendar. You know, this is all about time, looking at the project, the progress over time, the order of operations, and listing it out by these discrete names. So it literally gives you that time frame, what's going to be happening and when, what drives what. And then we get into what's called critical activities and non-critical activities. This is about the prioritization of activities. When I say critical activity, that means it's critical towards achieving that end date. When I say non-critical activity, it's basically saying this activity doesn't necessarily need to start on this date because it won't impact the end date if it's not started on that date. So that's really how we prioritize based on criticality, or what we call in this program total float or total slack. The building blocks of CPM is very simple. You know, what's perplexed me over the years is that a lot of people call scheduling the black hole of construction. And I think that that's really somebody actually saying, I don't actually get it yet. But if you think about scheduling, it's pretty simple. You know, if you were to plan anything out in your life, you'd probably, anything of complexity, not just your day, but like your month. If you were to plan those things out, you're obviously going to list things out, and then you're going to assign order. You may not always be assigning durations, but in this program, think of it like an Excel spreadsheet where you're listing out all the things that need to happen. You're assigning a duration. And then most importantly, you're listing in there, what are the predecessors and what are the successors? What is the order in which this is going to happen? So for example, right here, you'll see that there's a little 3. It says that procure roof drainage can't happen until number 3 happens, and that's number 3 right here. That's our identifier, and that says that I can't start procuring until my design is done, which makes all the sense in the world. If you look down here, we'll see that here's an activity that said I can't grade my new slab until number 17 is done, and that's demo existing concrete slab. So you're not going to be putting any new slab in there until a new concrete slab, till the old concrete slab's out of there. And the successor to that is number 19, which says right here, form and reinforce footing. So you're not going to form and reinforce until your grades are done. So those are really the rules in which this schedule lives by. And what happens is an algorithm takes that information and it starts to create you know, these start dates, finish dates, and these float values. So right now, once you punch all that in, you'll hit schedule, and all of a sudden these start dates, these finish dates, and what we refer to as total float gets calculated. And then it gets visually placed on a calendar. So this is really about a mathematical approach to managing a list of relationships and activities amongst those relationships, all in a format to know the start dates and finish dates, to know the priority, and then it gets graphically placed into a chart that basically tells you, you know, what's going to start and when, and what's absolutely needs to get done on time, and what has a little bit of room for delay, and that's pretty much indicated by these lines right here. Those are the relationships. But again, I'll talk a little bit more about float. I put a light bulb here because this is probably one of the most important concepts of all CPM scheduling. And the reason it is because it actually gives you the ability to prioritize. Float is basically the number of days that an activity can be delayed before it impacts the end date of the project. Why is it relevant? Well, as I mentioned a couple times, it enables people to prioritize, and it also highlights the most important path of the job, and that's the critical path. That is, the critical path is the path of least most resistance, the path that extends from today to the end of the job, the activities streams of those paths, on that path, that if any activity is impacted or delayed on that path, it will have a direct effect on the end date. And that's very important here to note, is that we're really concerned about end date. You know, when it comes to a complex project, we want to know about the end date as an owner or a contractor, because time is money. We have an estimated amount of time to get here. The owner on the other end of the spectrum is looking to receive an asset on that date and probably generate revenue. So it's very important to know when that end date is, and it's more important to know which activities are going to impact that end date if they're not met. The critical path, as I mentioned, are these red ones. It means they have 0 days of delay. As you can see, this red guy impacts this red guy, impacts this red guy, and so on, all the way to the end. So if any of these activities are actually delayed, it's going to push out the end date. So there is no room for delay on those activities, which means come hell or high water, you better get enough resources on those activities, or else you're going to impact the end date, which is going to result in additional money or losses. And then here's an example of something that's not critical. You see this really long line here is basically telling me I've got 25 days for this activity to get completed before it actually impacts a critical path activity or the end date of the job. So being able to sort of see that, knowing that you don't have enough resources probably, you can sort of juggle around where people are working in line with the plan such that you'll get it done on time. That's very important, getting it done on time. There's also a thing called organizational structures. You know, that's one other aspect I think is very important to point out. They're either called work breakdown structures or activity codes, but short of those organizational components, you have literally a list of activities in an order over time, which, you know, if you look at this, you can see that it's sort of bouncing around a little bit. It says pour 11th floor, do the rough-in and fire alarm on the 3rd floor, you know, based on these start dates. And you know, that's a little confusing. So what these programs have also built in is an activity code structure, which basically assigns different things to it, such as location, trade, you know, phase. You know, once you put that in there, you can actually summarize your schedule up so that it's a little bit more visually pleasing. And in this example, what I've done is I summarized it by phase, then by trade, and then by location, such that I can look at my job at a higher level, and I can see that, you know, across, you know, I'm first going to work on some of my pre-construction. Once I get into construction, we're going to do some site work, then we're going to get into foundations. I can pop open this foundations tab and see what all those components of work is that's driving that. I can look at which activities are critical, which ones are not. I can then look at, as we get into the structure, what's the order of operations at a high level, and then I can actually open them up and see what these discrete activities are. So that's really, to me, the component. This component of a schedule is very important because it allows you to actually understand it. It speaks to you. It actually organizes it in a coherent manner that the brain can understand. Whereas if you just have this list of activities, which could be in the thousands, I've seen a 274,000 activity schedule before. It's just not going to make any sense. This is going to just cause more confusion. So that is why these activity codes are there. So if anybody on this call is ever involved in a project that doesn't exercise the work breakdown instruction functionality or the activity codes, then it's going to be very difficult to comprehend the actual schedule in a manner that speaks to the trades, in a manner that speaks to the construction team, speaks to the owners, speaks to the architects. So that's why this is important. And if I'm speaking too quickly, please let me know. I'm trying my best. I know that I got quite a bit of stuff to go through. But anyway, in a nutshell, that is what scheduling's all about. It's activities on a calendar. I'm going to go back to this guy. It's activities on a calendar with durations, with logic, such that a computer program could take all that information, create a plan, and then prioritize it such that you can see what's going on and when, in what order, and it can also be organized into discrete components that allow you to holistically understand the flow of the job and the plan. Moving on into the next subject matter, now that we understand how does this program actually work and why is it effective, which it is very effective if used well, but something that's very, very, very important is quality. This is really where I think the industry has run into problems. Quality, like I said, P6, Microsoft project, they came out with these tools many, many years ago. They were based on this process that was developed in the 50s that worked. Worked when a team of scientists used them, but that team of scientists didn't actually prepare a user's manual for best practices in scheduling. Rather, Primavera came along, created an automated way to schedule, and then sent it out to the world, assuming that everybody actually understood what's the best practices, and that's not what happened. That was not true, which has obviously resulted, in my opinion, in a lot of problems. One of the reasons that I think that I ended up in the dispute world was there was such a big demand for it, and forensically reconstructing these jobs was important. But through that experience, I realized that, there's problems here. People don't actually know how to build these schedules very well. So I think it's very important that we talk about the quality. Now, there are some tools out there. They've been around for a few years that help assess quality. As a matter of fact, our product, hinges on quality. But really, quality to me, most people in the industry think it's, is it a good order and are the durations right? And they look at the thing and they say, okay, well, look, check it out. This looks like it's in a good order and the durations look right. But there's more to it. Is there enough logic? Are there bad habits been built in? Is there sufficient detail? At the highest level, this is what we're looking for. We're looking for sufficient detail. We're looking for all necessary logic, not some, all. And then we want to make sure the durations are accurate. But one thing that's very important to point out, and this, as much as it pains me to have to say it, because I am a person who doesn't believe in perfection, but quality needs to be nearly perfect, for a schedule to even be effective. And I think that that's really what the industry has not necessarily understood. And the reason that's the case is because since this is arguably about prioritization and criticality of those activities, if one missing logic tie exists, the whole critical path can be thrown off. And then you don't know what's driving your end date. And then you don't necessarily know where to put your resources. So it is so imperative that quality is hit in order to ensure that critical paths are accurate, such that the schedule can be a useful tool. And most projects, guys, I got to tell you, most schedules I've looked at, I'd probably get into the 80% range, are lacking in quality, which basically tells me that 80% of projects are at risk of not being managed optimally, which I think aligns with the industry of what we see, that 90% of projects are over budget and or delayed. So this is a big issue. This is why we focus on it big time at our company, but I wanted to make sure that this is burned into everybody's brain. Without quality, you might as well not be scheduling, because you don't have the ability to prioritize at that point, and therefore you're going to run into problems, and you're probably going to argue over them. That's the worst part. If you don't have quality and you think you do, and then you really don't, and then the project gets mismanaged and the end dates suffer and you didn't realize it was going to happen and all this money's lost, well, there's going to be disputes. And to make matters worse, you can't even figure out why, because the schedule didn't actually have good quality. You have to actually reconstruct it at that point and then analyze. You have to put quality in after the fact, which is after the money's gone, to even be able to actually understand what it should have been and what happened and where did all the losses occur. Quality can be assessed through analytics. This is what's called the Dcma Methodology, was the original version. This is a screenshot from our program, but what we track is, we want to know how many activities there are. We want to know what types of relationships there are. Generally speaking, finish to start activities, which says I can't start my successor until I finish my predecessor, is highly recommended. There's different types of relationships, like start to start, which means I can't start activity 2 until activity 1 has started, or a few days thereafter, and simultaneously finish to finish is the same thing. I will not finish activity 2 until a couple days after activity 1 is complete. A good example of that would be drywall and paint. I will not finish my paint. I will not start my paint until 4 days after I start my drywall, which may not be completely done on the floor, but to get efficiencies, I'm going to start it. And I therefore will not finish the paint until the wall's up, and probably a few days after that. So that's, tracking those types of relationship. The one that you want most of are finish to start, because that eliminates the risk of trade stacking. Some of the more important indicators of this are missing logic, constraints, and high duration activities. These are our driving indicators. These are the ones that cause the biggest problems. Missing logic, to me, being number 1. High duration activities being number 2. High duration activities are generally any activity over a month or 2 in duration is at risk of essentially hijacking the critical path, even though it could be erroneously. And then constraints, there's 2 different types. There's start constraints and there's finish constraints. Start constraints are designed to pick a point in time where you think an activity would start, which could be months down the road, which sort of defeats the purpose of a logic-driven schedule, to just pick a date out of thin air and say, I bet it'll start then, which could be misleading on the critical path. And then there's finish constraints, which basically are things that people build into schedules to enable, the user to know that there's a drop-dead date for finishing, and anything past that is late, which then turns into negative float, which then turns into more activities that appear critical. So those are the things, to me, that are actually driving the ability to get an accurate critical path, as well as the ability to actually manage a schedule effectively. Here's a little cheat sheet I've provided. One thing I'll tell you guys is I'm going to send this slide deck out. We're going to put this video up on our website, so you'll always have access to it. I really hope it's helpful, but I also wanted to provide this cheat sheet. I want you guys to have access to this presentation on your desktop in the event you're ever in a situation where you're actually sitting there trying to understand what's going on in this discussion about schedule and what do I need to know. I want this to serve as a reference that you can go back to make sure that you feel good about what's going on, that you understand the lingo, and that there's no red flag issues that are cropping up that you're unbeknownst to you. As you can see, generally speaking, we want to give you a metric of what's acceptable in terms of a percentage. So this would be the frequency of occurrence over the total number of opportunities of occurrence. What's okay? This basically says, it's a little risky once you get into this level. For instance, constraints, you should have less than 2.5% of your activities are constraints. Between 2% and 5%, where this is a little excessive. And if over 5% of your activities are started by constraints instead of logically driven, you've got a problem. Same thing with missing logic, although I personally believe that there should be 0 missing logic ties in any given schedule. The more activities that have a predecessor and a successor, the more logically driven a schedule, the more that this tool can be useful for managing the work, because one of the other important things that happen through the updating process is that, things do happen, other things don't. Things take longer, other things don't. And when you update your schedule at a given point in time, it actually tells you the plan going forward, which could shift the critical path. But missing logic makes it difficult. Missing logic makes it so your schedule's not as reactive. Like one activity, if it doesn't have a successor leading to another activity that's important, well, if that activity is delayed, the successor activity is going to basically, according to the schedule, think it's on time, and all of a sudden you've got a problem that you don't even know about. So I would say the number one thing, if you can take away from this slide, would be no missing logic. As a matter of fact, I'll show you a few examples of why does this matter. Here's a project that I pulled up. I've got thousands of schedules that I have access to, but I found one that had missing logic and finish constraints. Had missing logic ties, it had missing crew logic, and it also had finish constraints, which ultimately, pushed float into the negative. And anytime a activity has a total float of 0 or less, it turns red. So in this case, you can see that somebody's got a schedule that basically says the whole job's critical. We've got underpinnings critical, site work's critical, foundations are critical, tower work's critical, and then once we get through that, the enclosures and roughing are going to get critical, and then after that, the entire building's critical. So what do you do with that? Do you just sling bodies around everywhere just because everything's critical? You're not managing to an end date. This is asking you to manage to an end date that's been blown. And the reality is it's been blown. So what we need to do is think about getting rid of that finish constraint so we can see what's called the longest path. So I've done that. I removed those finish constraints, just took them out. There was 2 of them. 2 finish constraints made this schedule look like this. Made the user of this schedule think that, wow, this whole project's critical and we need more resources, which again would result in inefficiencies if the trades are tripping over each other and whatnot. So costs will be incurred for inefficiencies, additional costs will be incurred for delays. This is a recipe for failure. So I remove those, and what I start to see is that longest path. I see that one long path that's moving through the structure. It's getting into the tower of the enclosure. So structure's going up. At some point, the windows are going on. And then at the end of the day, the last critical part is the 19th floor, which sort of is a red flag to me, because if you think about a payment application, I would say 50% of that payment application is in the interior trades, yet the critical path is not. So I see a problem here, and this is a typical problem that I see is when you see the trades, the critical path going through the building and then into the enclosure and then ultimately on the top floor. That means that there's crew logic missing all throughout here. Another indicator of that is when you look from area to area and you see that total float value slowly going down to 0. It's basically saying this can be delayed up until this point, this can be delayed up until this point, this can be delayed up till this point. This can be, it's basically saying if worse comes to worse, every floor can happen at the same time, which we all know is a problem. That is impossible. And that's because they haven't actually put in crew logic. So what I've done is I've said, okay, well, I'm going to go put some crew logic in. I'm going to go connect drywall activities from floor to floor and millwork activities from floor to floor, just to show that there is going to be a crew. We're not going to be able to move on to floor 2 until we've started floor 1, and so on. And then once you do that, what you see is a real critical path, one that actually makes sense, that makes it say, okay, so the structure is going to be going up, but at some point in time, we're going to have to get into those interiors, and that's where all the action's going to be. And if that's delayed, all that's going to cause a ripple effect throughout the job, such that the end date's going to get kicked out. So this is really where you start to prioritize your resources. At this point, you can actually go start to think about, how am I going to make sure that we don't get delayed, even if there are problems? How many resources are we going to need, and are we going to need a backup plan? So that's really the starting point for actually a successful planning process, is making sure that those little nuances aren't there. And like I said, a couple little issues changes everything. And not knowing what your critical path is a problem. that results in disputes at the end of the day. And the disputes actually happen because you were managing without a schedule that really made much sense. Another example is the long durations. Here's an example of a different schedule where we have this, critical path going through the superstructure. As we know, we'd like to see it go through the building and the interior trades, but we don't. We see it in elevators. So this is basically telling me that in order to effectively manage my job, I'm going to need to make sure that the superstructure goes up on time, that the elevators get placed on time, that we finish up tying up the roof on time, and then we work on those units where the man hoist is, which that doesn't seem right. That seems odd. It seems like way too few things that can drive a job, and it just doesn't make sense. So once I remove this or shorten this into a couple of different activities that were shorter, we see that the critical path goes through where we think it should go through, and that is the building, and most of the interiors ultimately ending up in startup and testing. So yeah, little things can change everything and put a job at risk. And that is why I say that quality is probably the most important metric of them all. Another example, here's where a activity was, somebody came along and said, hey, this superstructure work, we're gonna start it sometime later this fall on a specific date. I think it's 8/31. And then they, ran out the schedule, and all of a sudden there's a critical path that starts, in the fall, and all the activities leading up to that aren't actually critical. So visually thinking, if you're showing this to people, they're all could potentially be thinking, well, between now and the fall, we've got room for error. But once the fall comes along, we got to start this on time. Well, the reality is once you remove that, you'll see that a critical path does form, and it does highlight the areas that you need to be focused in on hitting your dates. And that's really what you want. It's so important to have that knowledge of the critical and near critical paths for managing your resources. So the guidelines that I have here that I want you to remember, that obviously I'll give you access to this after, and I'm already halfway through the hour, so I've got to sort of speed it up. Number one, every activity except for the start milestone and the completion milestone needs to have at least one predecessor and one successor. It's not hard to do that, but I always see schedules with plenty of missing logic. But the reality is if you put one predecessor and one successor on every activity except for the start and completion milestones, because technically you can't, because it's the start milestone and the completion milestone. Nothing can happen before and nothing can happen after the completion milestone. If you put it on every other activity, you are doing one of the best things for your schedule, and that's applying enough logic. No finish constraints. That negative float is a killer. It misleads everybody into thinking the entire project is critical. You don't know what's more critical towards managing an end date, and at the end of the day, you end up with inefficiencies and additional delays and arguments. Number of star constraints, let's make them a minimal. They are useful, but they need to be thought out. They can't be just everywhere on the project because you're not, familiar with how a logic-driven schedule works. I would say that it's important to keep the number of days on an activity, a construction activity, less than 20 days. That's a month. 20 work days is typically a month. You don't want any more than that, because an activity that's generally could be done in 10 days, but you put a month down or 2 months, it could take over the critical path and actually not be critical. I call it hijacking the critical path, just because it's got this really excessive duration and no logic really in the mid parts of that duration, because there's just not enough detail. Crew logic is important. Make sure that your major trades, that you have logic between those activities. Like, when a drywall contractor comes to the site, they've got work to do on every floor. The concrete essentially needs to be done. The windows need to be done. The HVAC needs to be done. We get all that. But we also need to factor in the fact that they're only going to have 2 to 3 crews, and you can't be working on 20 floors at once. So that constraint needs to be there so you can get some clarity on critical path and end date based on that constraint. And the most important thing I would point out to everybody here is, if you think that something seems off, I've been in a million of these discussions. I've sat in a ton of these meetings where people are arguing over schedule, and because there's a lack of understanding here at a pretty much holistic level in the industry, there's a lot of arguing between schedulers, project managers, and then there's the, corporate as well as the owners. The reality is if something seems off, it probably is. So you should look into it. And that's really important. Don't let that argument get to you. Go back to these slides, go do a little studying, make sure that you feel comfortable that they're following quality best practices. Getting into updating now. Updating is important because, if you have a baseline plan, which the baseline plan is called that because it's the plan that was created at the beginning of the job, and it's all educated guesses. It's all based on experience. It's not based on reality. So you got to know going into it that the baseline schedule is likely wrong or off from what actually happens. It's obviously using as much experience as possible to get to that point where you have a baseline. But chances are in this situation with the various vendors and subcontractors and architects, engineers, owners, contractors, everybody, things are not going to happen in accordance with plan. And things are going to change. Durations are going to become more clear. Logic's going to become more clear. But at the same time, the critical path may change. Progress isn't going to go exactly as planned. It never does, never has, never will. And knowing that means that you should be updating the schedule, because the beauty of this program is that you're putting in all these constraints, and when you update the activities with real information, all the total floats may change. But you need to know at different points in time, based on the data and the achievement of these activities to date, what does that mean for prioritizing going forward? Not to mention, since things do change orders happen, subs don't show up, problems come from equipment, materials, permitting issues, rain, all that stuff factors in here such that you need to potentially modify your plan. So if you're not updating your schedule to factor in those modifications, you're not actually taking advantage of this excellent process, in that you're not seeing what's based on what we know today. What do we do next, and where do we focus our resources? So that is why updating is important. I'm going to show you a couple examples of that. Here's a baseline. Here's a summary. This is a summary that's been generated in SmartPM, and the reason I'm telling you that is because it's a little bit different than what you're used to seeing. Not to mention, I'm going to plug my software. Just kidding. But we do want to show you that there is near critical paths. There's critical paths. This is generally one of the things that I thought was very important, is why we built this into our program, is if you go back to this schedule here, and even let's go back to this guy, these types of schedules, it's difficult to comprehend, and I wanted our users to understand at a holistic level that the brain could actually comprehend how this project's going to get built, which most of these scheduling programs can't do. I spent a lot of time as a consultant drawing these things out in PowerPoint and Excel, just so that we could actually understand, and my clients could understand, what's important, what's not, where's some potential risk, and how is this job going to be built. So if looking at a one-pager like this and looking at the structure and then getting into interiors and whatnot, and seeing when those starts and finish dates are, seeing when those priorities are, that's important. But like I said, it can change. So if we updated a few months, we see that nothing much has changed. It could have. But if I go next, all of a sudden, come 6-7 months later, we still do see criticality in the structure, but instead of it going into conveyance systems and then, inspections, we see that, oh shit, now it's in the interiors. And that's really where you need to actually understand that this is important to manage your resources. You're not going to be focusing on the conveyance systems. You need to get as many resources as you can lined up to do this interior build out, because that is going to drive the end date from here on out. And knowing when that happens is important. As you can see, it continues. So each one of these little dotted lines represents an update period. Each period thereafter. This left of the line is historic, forward is future, and we just always want to keep an eye on criticality. We want to keep an eye on progress. We want to keep an eye on end date. That's the most important part, and bringing it to a level that the human mind could actually understand, instead of a 50-page Gantt chart document that doesn't have summarized organizational structures and whatnot, is not going to get you there. I want to give you a quick do's and don'ts. I've been notified that I need to speed up, so I'm going to speed up. But really, first and foremost, some of the problems I've seen out there is people submit schedules months after the period of time. Like, schedule update is received 3 months after the work was, at that point. So for instance, if I was to submit a schedule update today for last May, what's the point of that? Why am I submitting a schedule update today for what was supposed to be happening in May? It's not helping anybody. Doing it less than once a month is another problem. If you're not updating your project monthly, then you're going to lose sight. Things change that quickly. Don't modify the schedule without field input. Because of this process, because there's not a ton of schedulers in the world, all the schedulers are, if they're even on the jobs, are spread way too thin. They don't understand what's going on the jobs, and they're not always getting field input. They're seeing end dates kick out, and they're making changes to the logic internally to keep an end date without actually talking to the people in the field as to whether or not that's possible. That happens on like most projects. The other thing is leaving durations. Quite often you'll see a series of durations for like activities like concrete, mechanical, electrical, plumbing, drywall, going floor to floor to floor, or area to area, that is consistent with what the baseline said, even though over the last 10 months, it's proven that the baseline was wrong, that the durations in the baseline were actually much shorter than reality. Not making those changes causes a problem. Not making those changes will give you the wrong critical path, potentially. So as much as it stings to have to go extend the project out even more because you think that you're delayed anyway and you want to keep that end date, and then going and adding durations might even kick that out, it's actually the right thing to do. What you don't want to do is crash the schedule. You don't want to just start ripping out logic because the end date was delayed last month. Assuming that you're doing monthly updates, usually when you update it, you'll notice that the end date gets kicked out. I mean, look at this right here. We started on 8/9, update 8/14, 8/28, 9/10, 9/5, 10/15. End dates kick out. That's construction. Don't rip out logic to make that go away, because again, the schedule becomes useless. Anyway, these are all pretty straightforward things. Happy to discuss those if you have any questions, but most importantly, don't assume that the quality is going to be there because it was there in the baseline. People do crash schedules. They do add change orders. They do not update the schedules frequently. They do not make changes that are realistic, rather hopeful. So quality suffers in that regard. So we need to make sure that we can see all that. Moving on, I got 17 minutes, I think. I might actually go a little bit longer. Hopefully you guys can stay on if I do, but I'm going to do my best not to. Changes to the schedule is a big issue. We all admit here, schedules, start out with educated experience, educational guesses, and then there's reality. Reality sets in, and then all of a sudden, things change, and you've got to make changes. So I'll tell you right now, a schedule that hasn't been changed at all in construction seems more fishy to me. But you do need to make changes, but they should be kept at a minimum. And they should only reflect reality, not hope. Don't shorten durations because you want it to work out. Don't remove logic because you want it to work out. You need to be trying to align the schedule with what you believe is possible. And then if you do that, then you're getting that schedule to a place of perfection, which is making it a management tool, not a reporting tool, a management tool, which in the end will save you money, not help your relationship like you're trying to do with the reporting tool. Which in the end, if you do report misinformation, at the end of the day, it ends up costing a lot of money and burning bridges. Always keep an eye on the changes to the critical path. That's an indicator. When somebody's making changes to the critical path, that means they're shortening the critical path most likely, or extending it, which in and of itself is another tactic for getting time. And then there's, mitigating those delays, trying to mitigate delays that have happened, bringing that end date back in by whatever means is another way in which, somebody's being hopeful instead of realistic, potentially. And then the other thing on the change aspect of things is you need to be studying quality, compression, and the end date over time, always. And that's really where we'll start looking at a little bit closer as we talk a little bit about delay. But just in my experience, I want you to know that most changes, most changes are usually in an effort to overcome delay. Be cognizant of that. Then there's also changes that will be added for change orders, which may be kicking out the end date, and added detail. Sometimes schedules start out smaller and then grow over time. I don't recommend that. I think the best thing you can do is try to come up with as detailed of a schedule at the baseline time frame and then just tweak it, and align it with reality. Because usually what I see is if they're not in full detail when the project kicks off, it's just because there wasn't enough time, or they had other more important things to do, because this is going to happen. But if you don't have a full schedule at the beginning, you don't actually know the true critical path of the job. You have a bunch of long duration activities. Anyway, with all that being said, I hope that was helpful right there, because changes are a big deal. Changes are another driver of disputes. But here's a couple examples of being able to analyze change. Here's a graph of all the schedules that were submitted, how many activities they had, and then how many changes were made, categorized. So you can sort of see visually what are the periods of time that I need to probably start thinking about excessive changes. And then I can simultaneously look at that through another lens of quality. I want to look at quality, compression, and end date variance along with my changes. And right here, we have an analytical capability to look at quality. And we see quality is on the rise up until a certain point, which right around the time they start making excessive changes is when the quality starts going down. So what we realize here is they're most likely manipulating things to keep an end date, probably, which is actually verified by this. You'll see that the critical path delay is increasing over time. We're getting up to 100 days of delay over time. And we look at this line here, which tells me the actual end date's only kicking out half as far. So that starts to tell me that recovery is being built in. So they're building in recovery to overcome delay to leave us with an end date variance that's far less than what the critical path delay is, which starts to lead me into a world of understanding compression. And now compression, if you're not familiar with compression, is when you're trying to do more work in a shorter amount of time than you originally planned. This is another issue. This is all about changing end dates so that you can still hit the end date even though delays are happening. The only way to get there is by compressing, and compression is an indicator of excessive changes. And as you can see right here, like we thought, quality's going down, delays going up, end date's not moving as far, and compression is occurring to a level where we should be very concerned. And this is all a recipe for telling you that the schedule is falling apart. So, like I said, when you're striving to get to perfection in the updating process, it's important to be monitoring this. You always want to keep an eye on change. You want to look at those changes and its effect on the schedule quality, delay, end date delay, as well as the compression. Because once you get into a compressed state, the end date ain't happening. And you're going to try to get it done anyway, and all the trades are going to start tripping over each other and getting inefficient, racking up dollars. Then the claims are going to come, and then you're going to be done late anyway. So it's a recipe for failure here. And now I want to talk a little bit about delay analysis, and I've got about 12 minutes, and I think I can get it done. Number one thing I want to point out about delay is that delay damages are mostly incurred when the end date moves out. A lot of times, for example, if we go right here, a lot of times you'll see a claim come in that asks for 100 days, and the end date's only kicked out 40. They've made some changes. Well, the reality is the only delay damages occurred to the end date of the job. And the whole point of that is because if you're a month late as a general contractor, you're going to be spending a month more of dollars on equipment, people, materials, as well as all your trailers, all the little things that cost money, your printers, your computers, your cell phones, all of that stuff racks up. And every month that somebody's there longer was not factored into the budget. And if an interim milestone is delayed 100 days, yet the end date's only kicked out 40, a lot of times people ask for those 100 days. But the reality is focus on the end date and the impact to the end date when studying delay. Now, understanding what actually delayed the job is more important. But let me get back to the other thing. On the other side of the equation, it's not only costing contractors money to be there longer, it's costing owners money for loss of revenue at the end of the job. This is where all the high dollars are. So contractors losing money, owners losing money. So basically the fight's about both of them wanting their money so that the other person loses 2 times as much. And that's really what these claims are about. And the only way to get there is to understand that historical critical path. Like I mentioned way back here, the only thing that can delay the job is on the critical path, meaning if you want to understand your delays, you need to go find what was the critical path at the time, because it couldn't have been this or this, because that has room for delay. It has to be the item that's on the critical path. So what you need to do is go find that historical critical path. And the way in which you get there is by looking at as many schedules as possible, the contemporaneous schedule updates, which requires quality. If your quality is not there, which means your critical path is likely off, well, then your delay arguments are infinite, because anybody can say anything and argue it, and nobody's writing any checks, and that puts projects at risk. So again, I go back to quality is so important for managing not only the job, but also the arguments. And again, you want to have as many schedules as possible in here, because each schedule, we do know things change. So those changes cause impacts to the job and or changes to the critical path. If you don't understand at different points in time when things changed and when critical paths might have changed and when progress resulted in critical paths changing, then it's still a lot of guessing. So you want to have these specific points in time for which you can get another lay of the land as if it was the baseline. But now you've got some changes that have occurred or things that didn't actually get done in time and the critical path has shifted. You want to know at what points in times those things happened and what decisions were made at those points in times in terms of changes, so that you can agree to them or not agree to them and determine if the schedule is usable for the analysis. Lots of people do different, types of analyses. Some of them just as planned, as built. It's basically taking your baseline and saying, okay, well, let's just go study the structure and see what delayed that, and then we'll get into, what delayed the elevator, and then after that, we'll see what delayed the punch list. That's not actually what happened. We do need to be studying what happened to the interior build out on that particular job. So yeah, with that all being said, delay analysis is about identifying the driving factors on the historical critical path that impacted the end date and resulted in extended GCs or revenue loss. And it's so important that quality is there in the schedule or they're unusable, and that accurate information, start dates, finish dates, percent completes are there at each update period, which can be verified with photos. And at the same time, they're submitted regularly to show you the different decisions that were made along the way. That is giving you visibility to what changed and whether or not that's a realistic change and whether or not it's an acceptable change and what that means for the future critical path, because those things change. I'll show you in a couple examples here. Here's that same example we saw before. Here's a time frame, 26 months to get this thing done. We see that the end date's kicked out 19 days in the first, 5 updates, and we also see that a lot more delays have occurred. But we do know that it's all in the structure. That's important. We need to go study these changes, and we need to understand why they happen to be able to assess responsibility. And it's not telling us it's somewhere where it's not. We agree, this was supposed to be in the structure. It remained in the structure. That makes sense. Now I've got to go study of those items that were supposed to be critical, which ones were delayed for how many days and why did they happen? But I'm also seeing a little bit of a red flag here. I see after the first 6 months, we've racked up a considerable amount of delay, yet the end date's only kicked out 19 days. So now I'm starting to wonder, what are they doing to the changes? But we'll skip that for now. And we'll look again at the next update. We see that there's 32 days of delay. And then we see that there's 27 days of delay and that the critical path shifted. We need to note that. We also see that between the previous period and now, the end date has kicked out only slightly, even though there's been quite a few delays in our site work. Critical path is now into the interior build out, end date's 27 days delayed. It looks like there's probably been more like 5-6 months of delay. So we know compression's happening, critical path's changing, but again, we'll think through that later. Finally, again, now we're at the 67-day mark. We see that, even more delays have happened in the beginning. So now I'm starting to wonder, is my delay analysis, this was my historical critical path. It does seem somewhat accurate. I do feel like my go-forward schedule is pretty aggressive and that we're probably further delayed than, 2 months away from our original plan. But nonetheless, at least I can see what's driving that. Knowing what that historical critical path is, using quality schedules to get there is very useful in settling out differences on why are projects late. And more importantly, if you know that critical path and you're following it and you're actually using these schedules the way that they were designed, you're probably going to manage better. You're probably going to know exactly where people need to be, and delays are that much least likely. Again, here's those same 4 graphs where we're looking at changes. We see that, wow, we had about 600 activities for most of the job, but then all of a sudden we doubled that and we added another 600 again. We added all sorts of changes in this period. And that actually happened right around the time where quality started degrading a little bit. So quality was getting better, and then all of a sudden it got worse, and simultaneously we see delays continuing to trend up, end dates not moving as fast as that delay was happening, which meant recovery efforts were placed in that coincides with our changes that are occurring. And all the while, we just watch compression get up to a level where we should start to be concerned. And really, this is where you have real conversations. You talk about the delays, you figure out why they happened, and then you draw a line in the point in the sand where you think the schedule fell apart. That's so important, is deciding, is this schedule right? Is this schedule useful? At this point, I don't think so. I think that on this 9/24 date, when the quality started going down, we have a problem. So I actually don't want to look at what happened in this period because it might not be accurate. It might not be an accurate critical path. There's different things that you can do with that. You can reject all the changes and rerun the analysis. But generally speaking, these are all indicators of problems. You want to stay on top of them. You want to use these processes to do it. But really what's important to get there is understanding, the scheduling side of things. 2 more slides and then I'm done. Number 1, there's 3 different types of damages that you should remember. Owner caused delay, they call it excusable compensable. That means that the contractor's excused from this delay. The end date is extended because they didn't cause the delay, and they get paid money for their GC costs. Inexcusable delay is essentially when a contractor caused it. This is the owner saying, I didn't do anything here. I'm not giving you time, and I'm not giving you money. As a matter of fact, you're going to give me liquidated damages because you caused a delay that cost me money on not receiving the revenue that I was supposed to get starting on a specific date. And then there's the excusable non-compensable, which is also called concurrent. That's where both parties are at fault. That's where both parties equally delayed the job. And what ends up happening there is the time is extended, but no money changes hands, no liquidated damages, no general conditions, which makes all the sense in the world. When 2 parties cause this problem, neither of them should be compensated, but the time should be extended. And last but not least, if you guys walk out of this meeting with these 5 things in mind, I think I would have done my job. Number 1, CPM scheduling is really an algorithm that allows you to list out work activities, give them relationships, and it calculates a plan. And it uses a term called float to prioritize that. And what float is essentially a gauge of risk of delay to the end date by that activity if not met. The other thing is, in order to be successful here, quality needs to be met. Take quality so seriously. Don't let a schedule not have quality. Don't let yourself not take a few minutes to make sure that it does, because it changes everything and it costs a lot of money to both parties. Another thing is changes are inevitable, but should be kept at a minimum to minimize risk, but also really should only highlight realistic changes, not hopeful changes. The other thing that I see a lot of is, people don't understand truly what delay analysis is about. It's about the impact to the end date, and the only way to understand it is understanding the longest path or the critical path driving that end date and all the activities on it at different points in time and quantifying it. And then finally, the industry is moving in a very good direction. I think the tools that, like the tool that we built and tools that others are building, the education, the people coming to this webinar today to learn is just another great sign. But the reality is the industry has so much to learn. If everybody out there actually sat through this webinar and listened to it and actually understood it, there wouldn't probably be nearly as many issues out there on the scheduling side of things. There would be less fights, there'd be better outcomes, but it's really one of the biggest problems, in my opinion, is that there's a language here that not everybody knows, and there's there's a process here that not everybody's really good at, that's happening out there, and no ability for people to speak about it intelligently because it's so complex. But I'm trying to bring it to a level that'll help everybody understand it conceptually. We also do that with our technology. So with all that being said, I appreciate you coming today. I'm glad you did. I hope I was helpful. If you have any questions, absolutely, please feel free to reach out. And thanks again so much. Have a great day.